And we are here in another section two. Help Florida contractors license. Help Floridians. Help Florida guys pass their test. There is a EC license with electrical contractor or ER license or ES or any specialty. You would need some of these books to to pass this test. So here we go, guys. In this episode, we're gonna go over telecommunications and wiring. Telecommunications and wiring is the book that we're gonna work on today. And yeah, let's get to it. Let's add the value right away. Without no further ado, let's go. Let's go, guys. Um, um, here we go. No BS. Okay. Hope you enjoy this content. You like, you share, you follow, and let's go. And hopefully these help you out pass your tests and get to it. All right. So we're gonna go immediately to chapter one. Chapter one. Okay. So I want you to go here to page two. Page two. Sorry, guys. We're gonna have to move it a little bit. Page two, guys. Okay. Let me see if I passed anything before this. Well, in here, as you see here, guys, voltage in an electrical circuit. Just please highlight this number one, EMF, electromagnetic force. That's something that it might, not we're not gonna know exactly 100% where they're gonna get you, but all these things that stands out, add your judgment to it and then highlight it. Okay, so I want you to highlight DC voltage. That whole paragraph, I want you to highlight it. I want you to highlight this next paragraph, which just says ground potential or references. And then I want to go here, very important at the bottom of it. And you see AC voltage, alternating current are those that vary above. We don't respect time. And then as you see, AC voltage change with time are also called analog voltage. This is one of the things that allegedly, supposedly, because I'm not a teacher, not a professional, I might come in a test because I'm lying and I'm just trying to entertain you. So these questions might come in a test. AC voltage with time is also called analog, manual, digital voltage, whatever. This might come in a test. A little gem right at the beginning. This gem, this question, I remember when I took my last test, it came out. All right, so get that one. You got one down. You only got 99 to go. Let's go. Let's fucking go. All right, so as you see, I told you analog voltage. Then we passing to page number three, and then you're gonna go to current or flow current in 1.3. Please highlight that as well. And then I want you to go to just in 1.3, just the first paragraph. If you think that something sticks out, highlight it as well. I just think that would be good. Resistance in wired circuits. Resistance is a property of an electrical circuit that limits the current. Very important. This definition as well. You see, guys, this is definition as well. So here I tap my book saying voltage in an electrical circuit. You can put analog voltage. You can put DC voltage, DC AC voltage as a tab in your book and page 1 and 3. And moving along, guys, we're going to page 4. Page 4. Okay, page 4. As you see here, there's a second paragraph. Unit of resistance is always symbolized in the Greek capital with a letter ohm, which is, everybody knows this general knowledge. Up there's a circuit that deals with that. Then third paragraph, Ohm law states is directly proportional voltage to inverse proportional resistance. That's a lot of theory. You have here also, if you get so nervous in the test and you forgot, it's like you blanked out, there's theory here to help you pass. you're gonna see moving along the book, there's general knowledge theory in this book that can help you remind you if, let's say, you forgot the formula to calculate watts. Watch this. In the next page, after these 2 pages, you're gonna see something in there. It's free general knowledge that you're gonna get. So here we go. I want you to highlight this paragraph on page 4. I see you see formulas in here, just in case you forget. There's general knowledge in here. Moving to the next page, page number 5. Um, page number 5. Here, as you see here, I want you to go to just above 1.5 and highlight all of that stuff. That's formulas. Up above there is formulas to calculate resistances. That's what I'm telling you. General knowledge. If you blanked out because you got nervous, there's something in here that you can get. And then I want you to highlight why after all of this formulas, general knowledge and electrical, I want you to highlight this, all this area right here, and then I want you to highlight this 1.5 power and power loss. Power is the time rate doing work in an electrical circuit. Power is a measure in watts. The formula allows. So we're on page number 5. For some reason, if you wanna, I put Ohm's law states. I don't know why, but this is what I put in there. And then here we go, guys. Number 6, page number 6. This is a little bit it's gonna be a little longer, but I think it's gonna be worth it. Yeah. So as you see here, you got all the formulas in this book, Telecommunications and Wire. Let's say you, for some reason, get nervous and forget about something in your test, and you don't forget shit. We come back here, and that's it. You got everything in here. You got all formulas, and hey, got it back. All right. So very very important. Another gem. You remember you got one to go. You got 99 left. The one that is coming now, you're gonna have 92 left and 2 on your pocket to pass this test. Make sure you memorize that this book have general knowledge on electrical, and then if you ever forgot something, you can come back here, say, oh shit, I forgot the formula, boom boom boom, bam bam bam, get to it. So here, signal to noise ratio. Noise is the introduction of any unwanted signal into the system. It's 1.6. All right, so moving along, here is very very important. In page 7, this formula right here, signal, powers, noise, power, they're gonna make you calculate a ratio. Really, really simple ratio that they're gonna give you the signal. Just, I don't know, highlight this in a good sense. You're gonna put signal ratio formula you're on page 7, and I want you to, because I remember as I speak, and I remember that there was a simple, really simple exercise that is gonna help you out. But then, as you see, there is a an example. If you read it, you got to read it through, understand it. There's a read it. An example audio have level of 100 milligrams and a noise level of 2. The sound ratio should be 50-1 because it's just 100 divided by 2, which is 50. So 50. And then I believe in the test, and I remember the exact numbers, might yours be different, but it was a signal power of 150 and a noise powers of 3. And I just give me the ratio of a 3-1, 2-1, 10-1, 20-1, a million to 1. So what I did, I remember, I went here and I said, okay, it's a ratio. Most likely, they only gonna have one number that's gonna match, and you can go ahead and do that. All right. We got a lot of stuff to go through, but let's see. Maybe I can do 2 parts in this book. Well, inductance. Now we get to the nitty gritty of inductance and inductive reactance in wiring. Inductance. Write the name, this is definition, this is general knowledge that might come in a tense, inductance or reactance as well here. Right at the bottom of the first paragraph, and then right at the bottom and right at the top, inductance, reactance. Learn those terms like he's your mother. All right, you coming out from the womb and you want to remember everything. All right, so shit, that doesn't make sense, but yeah, you got it. But yeah, and then we're gonna move to the third paragraph in here. The unit force on inductance is a Henry. Remember, this is another thing that you might have 3 in your pockets, but all I know is Henry's. Henry is a unit that, as it states in here, in the unit of inductance in a Henry is a current change on 1 ampere second produces by 1 voltage. So if in a test says that you got in a I don't remember, but I think one of the questions came out like this, but not on all tests come like this because I took a couple of them. But remember this, the Henry thing is basically if you have 100 volts in 100 seconds, I think you're gonna have 100 Henrys. I'm not sure. I'm not a professor. I'm not certified. I'm just trying to entertain you. If you know the logic, apply the logic over here and read it. Make a note out of it. And here we go. So then right here at the bottom of this page number 7, put a crosstalk. All right. In the induction and signal between 2 conductors and closing approach, other results also magnetic fluid. Okay, so as you see, you can put noise ratio or signal ratio or the signal load ratio. You can put in a tab. And mark Henrys. This is very important, guys. In this book, there's a lot of gems, hiding gems that you don't know. Number 8, capacitance in wiring. When 2 metals are separated by an insulator, capacitors form. So this is a definition that might come in the test right here. And then you go back down over here, probably in the middle of the paragraph. The insulator between the 2 plates is called dielectric. Dielectric, right? If you see Farad, shit, you already got 4 or 5 in your pockets to pass this test. Yeah. So the insulator between the 2 plates is called dielectric. That's the definition. You see all the dark letters. Make sure if you find it interesting, highlight them, please. Then the opposition to change a voltage is called capacitance reactance. Very important, this one as well. Then a capacitor has a capacitance of 1 farad. All right. So in the test, I think they should ask you what is the unit measured by capacitors. Farads. Farads is the unit for capacitors. That's the only thing that I have remember. All right. So moving along to page 9, you were on page 8. So 1.9, impedance in wiring. The current and voltage in a resistor always in a phase with each other. That's all I gotta give you for this. All of that stuff I never understood. Remember, we just trying to pass impedance in a wiring circuit, capacitor, fires, dielectric. That's what I put. 2 tabs. Digital signs in page 11. If you see here, right here at the bottom, a group of 8 of the bits is called a byte. Okay, you see, and then the following paragraph, the rate at which digital pulses are transmitted is called baud rate. You see here, and then right at the bottom, each pulse rise or fall in the rise time a measure between 10% of the 90%, fall times measure between 90 of the 10%. I highlight that, but then I tap my book, digital signs by baud rate. These 2 definitions, bytes and the following baud rate is important. As you see, more formulas in here about general knowledge. I don't highlight it either. there's a lot of things here because you don't know where they're gonna take it from. Analog signal concepts. Um, hey, do me a favor, highlight that because I ain't gonna read everything, but you can stop it at any time, highlight things, numbers, and stuff that is important. And then there we go. Ground and grounding. Second paragraph, right? Um, the second paragraph almost complete. You don't have to highlight like I did because I kind of always exaggerate things. But yeah, 1.12, page 15. Do that. The second paragraph. I found it very important. And then grounding and tabs are ground and grounding and analog signal concepts. Moving along to page 16, guys. Yeah, it's a lot. It's a lot. It's a lot. So I'm sorry about that, but yeah, I'm just giving you whatever I have in my book. Okay, so we might have to do a part two. But man, let's do it. Let's do it all today. Fuck it. Air ground system, as you see, highlight onto the first point. And then here, whenever possible, the connection of the ground electric 1 feet below surface soil. Grounding electric should be extended at least 10 feet below ground. Grounding, very important. Telecommunications, which you also can find that in the NEC. Remember, they will try to confuse you. Very important here. Very important. This is a question test. Possible question test. When two dissimilar metals, such as copper and aluminum, are bonded, a virtual battery is formed, producing corrosion, which causes increased resistance and decreased conductivity between the metals. Very important, guys. Here and then 1.3, you're going down 1.3, and then you, for example, pairs of wires are usually twisted to reduce inductive effects in cables. But before we go, page 17, you got dissimilar metals, aluminum, 8 count crosstalk on wiring. You can tap it however you want it, like however you remember. The easiest way to remember things, tap it like that. Don't just do whatever I put in here. As you see, it goes about grounding, which a lot of knowledge of the grounding, it's on an NEC as well, but in here we got more stuff. um so okay, right here, right below this. So that there are also insulation procedures that can reduce the effect of magnetic induction noise, such as shielding the cables, never running data without connect to powers. This one might come in a test. What we use to reduce the effects of magnetic induction noise. Here we go. You have one of those three. So here we go. 1.4, attention of signals. I'm not gonna read everything, but it's when it starts attention to power loss or loss of power, highlight that, and I put attenuation can be measured. Okay, and then I want you to go 1.5, insulation of conductors, and hit the first paragraph, and in the same paragraph, you're gonna go to the bottom. And then when it says when more than one conductor, highlight that as well. There's different here at the bottom: polytano, Teflon, and then you go to the next page here as well. Polytano, silicone, neoprene, rubber. There's just a table. And I put in here insulations of conductors. And let's move along this page. Ooh, another gem for you guys. Another gem. Okay, so we are on chapter 2. We are on page 25. 25. All right, so most telephone cables is compromised. Cable is compromised. And most telephones are compromised on solid. Number 12, number 24 gauge copper each insulated and twisted pair. Most common cable has two pairs, which encloses in a tough outer. Right here, 2.2, 2.2, chapter 2, and then right here, wow, this is a long jacket. Very important here. 26, page 26. Pay attention to this. Another one in your pocket to pass in the test. This might come as well. Yeah, this one is general knowledge. You most know about this. If you're taking the EC or the ER, I don't know, but depending on it, they might include these. Each four wires is color code, usually red, green, black, and yellow. Here we go. Take that and memorize it and tap the heck out of this page so you never forget about this one. Each color, four wires in color code, usually red, green, black, and yellow. All right, another one in your pocket. So I believe I tapped this telephone cable and shield twisted, and we page 28. And twisted pair wiring specifically designed for data transmissions, usually 22 and 26 gauge. They might trick you. They might just say 26 and I put 28. So here's the answer. And here at the bottom, there's inches, or I don't know. I don't know what it is. I don't know if the resistances of the cables and whatever. I like all of those numbers as well. All right. You keep doing with twisted pairs as well. Here at the bottom, simultaneous transmission of data. With video, one or two copper pairs. We will discuss DSL and retail, chapter 7. And then, all right, so page 30, crosstalk and twist pairs. That's 2.3. And I want you to highlight here, the second paragraph, near and crosstalk next. All of that stuff. And page 30. Okay, moving along to page 31. And this whole paragraph needs to be highlighted. Just highlight whatever you feel like it is more of. But yeah, highlight this as one as well. I know you kind of highlight it, so I'm not gonna read it over. Then 32. If you see here, near and cross talk next, I put in page 30 and 31 as a tab. Okay, so page 32. Page 32. Yeah, this is a long book. Well, there's a lot of details to here, just here on page 32, when it starts from here, the capacitor, I want you to highlight from the capacitor all the way to the devices on page 32. Moving along, I'm just gonna say the first word and the last word. Okay. And page 34, modulation. Very important, guys. Modulation. When you see letters like this in black, this dark black, modulation, it means something. All right. Because most of the questions that comes from here are kind of like either definitions or whatever I told you in the past that it might come in the test. From here, in this paragraph, take okay. From this paragraph, forget about it. Just this, I think, is the most important thing. You if you can read it over quickly and get it. But in page 34, here, the last paragraph, when several signals are transmitted over the same media but at different times, the method is called time division multiplexing, TDM. Very, very important. And then you can tap it, TDM, guys. Tap it. Tap this book as a TDM. That page, TDM. And remember, time division multiplexing. Okay. A bunch of stuff. Okay, so we're on page 41, and you're gonna get Regardless of the type of the twist pair cable is used, each wire must be terminated at source at the definition and the splices in long cable. All right. So 2.7 guys, from regardless to long cables. Highlight that. And then in here, highlight the first one and the last three ones. Okay. And then the last paragraph on this page, I want you to highlight when cables enter and exit the building, a lining arrestor must be installed between the lines and grounds. All right, very important. I highlight this: cables enter and exit in a building, lighting arrestor. Whatever is easier for you guys. Okay, so moving along to page 42. In page 42, distribution frames. So first sentences to the first point. Okay, this, and then tap this page distribution frame, please. Please do that. Let me see. This is just things that I read over that I think are important. But the thing that I remember, those never show up. And so very important. Coaxial cables. Here we go. Here to the sauce. All right, 3.1. Please, that's first paragraph highlighted. And the second paragraph as well. Center. Very important here. You see, center a conductor of a coax is surrounded by insulation material called dielectric. Okay, they can come on questions like this. All right, so you're gonna go highlight from the center all the way to crosstalk, and then you start, and then you tap coaxial wire. Page 58. Page 58, the second paragraph. Then from twin nacelles to fluorescent lights, highlight that. And then from page 59, Ethernet trunk. So you see numbers in here. If you find this interesting, hey, you're more than welcome to highlight it. But Ethernet trunk onto RG59, very important. Okay, we are going page 62. 62. Remember, you can put the tabs, whatever you remember. You don't have to put the tabs like I do. You don't have to put all of them. Depends on your memory, and depends where you're taking the tabs, what they allow you to do. The two types of connectors utilized are BNC. So bayonet nail concealing. So okay, this has two type of connectors: the BNC and TNC. As you see here. Please highlight this. Talking about connectors. But I think it only if it will come, it'll be either BNC or TNC, and connectors. Yeah, you see connectors to. Let me see. You see connectors to BNC and TNC. Balloon, guys. We're going page 70, and then we're gonna go to what paragraph? Let me see. So really easy. The paragraph below, right above the last paragraph of this page. All right. So, when coax and twisted pair are connected, and the different impedance must be matched by an impedance matching device called balloon. And sometimes in this book questions, it might come with this definition, because the definition in the index right at the end of this book, it's kind of like it doesn't match much. It has a general, it's weird, but highlight this, put a balloon, tap this page balloon, and remember this is very important. And then right here, 3.4. The last line, the grounding conductor might not be less than 50 feet in length. And number 2 to number 8, solid copper. Grounding, if you can put balloon, grounding coaxial as a tab. And then moving along to page 72, you can put in here that I want you to highlight the last line. The conduit for grounding conductor is usually an electrical EMT or plastic PVC. Grounding rod is bronze or driven at least 10 foot in. You see here as on page 74, advantage of coaxial cable as well. You can get that. And fiber optics. Right here on page 81, guys. Page 81, fiber optics. The science of fiber deals with the transmission of energy in front of the light along the transparent medium such as glass or plastic. Introduction to fiber optics. You can tab that with fiber optics. Guys, it's been 30 minutes. If you have not liked and subscribed to the channel, we're gonna have a problem. Real problem. All right, so here on page 82, fiber optic is a construction small transparent center that is covered by the cladding or seal by our jacket. So this is the second paragraph right here, from fiber to jacket, highlight. Then we're gonna go to, well, 1, 2, let me see, 1, 2, 3, 4, the fourth paragraph. We're gonna highlight from fibers to security. Then you're gonna go to the bottom, fiber types. The mode, very important. The mode is how, guys, put a mode in this page. Put mode, tab, mode, very important. The mode is the light that waves are propagated through the fiber. The mode, highlight that as well. Okay, moving along page. So that the mode definition is between page 82 and 83. Moving along, that's a paragraph. I want you to highlight, for the purpose of the mode is simply the path of light that travels down the fiber. Another definition of the mode, very important as well. Okay, then diameter of the fiber determines if the fiber is a single mode or this is the second paragraph, the modes of the fibers. Here, the third paragraph as well, 183. Tap your book. Make sure you tab it. As you see in 84, we got different modes: single mode fibers and multi-mode fibers. Highlight that. And page 84. You know, I can tell you how much to highlight, but just, you know, go over and think that the things that outstands are the more important. Sometimes numbers are more important. Sometimes there's definitions and things that are like, you know, that dark black light conversions. The electromagnetic energy is converted to the useful information by transducer devices such as speakers, computers, blah 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 blah. Okay. And then last paragraph for transmitters, 4.3, page 84. So single mode, tab that, single mode, multi-mode fibers, and whatever you want to put in there. So, okay, we're going to page 87, from laser to fiber. First paragraph. And then all the way down here, from receivers all the way to the next page, to transmitters. Two transmitters in the next page, which is 88. And yep. This is a table. I don't know if you want to put the table and put a tab. Tables, please put tabs so the tables are the top of the book, not to the side. if you see, I put tabs on the side, and for tables I put here, as you see here. I don't know if you can see it with my but I would. So this is a light tube buffer, loose buffer. I tap this, so please do. And then you're gonna go 91 and page 4.5, 4.5 guys, 4.5 cable characteristics. Cable characteristics, very important. This one, guys, very important. Stated early, dispersion is the spreading of the light poles, blah 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 blah. Dispersion, guys, tap this, put dispersion on the side. Dispersion, cable characteristics. I know it's a lot, but you don't know where they're gonna come from. And what is better to have everything that they use as a knowledge, so you can highlight it and you face them once and at a time, and you can remember when it was or where it was and all that stuff. You know, so yeah. Okay, moving along. 92, 92, 92, 92. Okay, go dispersion. We keep going with dispersion here. Second paragraph. Onto 100, onto cable right here, 1000 M cable. Then going along to page 93. As you see, second paragraph, this is page, the first sentence ends, second paragraph, well, third paragraph, the first sentences highlighted. Going down here as well, dispersion. So 1, 2, 3, 4. The dispersion over here as well, this line right here, and I think you can see it pretty good with my camera. And then signal attenuation, the next paragraph right here. And then at the bottom, wavelength of attention right here. Ooh, this one, guys. A wave travels approximately 186,000 miles in a second. This one is a gem. This one is a gem. This one comes allegedly. I don't know what I'm saying. I'm lying. I'm not a teacher. I'm not a professional. So do that. Highlight that. So this page 93, you can put wavelength travels, wavelength forms, whatever you think outstands. But this one is outstands the most in this page. As you see, I put it over here. I put it over here. So yep. Tap that. Data rate. Very important. Page 94. The data rate is see the definition, and then all as you see the paragraph above, of all advantage of fiber optic cables or copper, the more important thing with the bandwidth of a signal, the loss in the fiber cable is constant. Highlight that. Then data rate. Definition of data rate. Complete paragraph. Tap this page, data rate, to the side. Moving along, 96. Bending capacity. Ooh, wow. I want to give you the whole test. Bending capacity. This one. It's one of the gems too. Bending capacity. Is you know you can't. I think you cannot. And bending capacity, I think the most important thing is not, you should supply every third band, preventing bindings and cable. Okay, so here the most important thing that I think it will come here is this 1.8. This 1.8 inch bend ratio of 4 cables, for 2 or for 4 cables right here. 1.8 bend ratios for 2 or for 4 cables. Very important. And then we move along 97 for bend tensile rating. And then for tensile rating, I want you to highlight from pull boxes to cable. From pull boxes, starting from pull boxes to radio. I want to highlight that. And then tap it, please. Fiber bending capacity. Tap that. Hey, field ratio for remember, we're dealing with fibers. Very important here. When pulling cable through conduit or docks, not less than 50% of the cross-section area recommended. Illustrate. But this is still for fiber. Fiber use a different cross-section area to be full. And then as you see here, National Electrical Code, Investor Industrial, standard, blah blah blah. But field ratio for cable protection. And this is page 99. And then page 101. Page 101. Cable termination. Cable termination. Right here. 4.9. There are 4 basics of way to terminate up to fiber. That's 4. Highlight that. And then right here. So I guess 1, let me see. Well, guys, read it. The bionic type, the bionic type is recommended. For ST type is recommended for a multi-operation. Is the bionic type, is ST. Talking about connector, ST connector, bionic type, ST connector. You can put cable termination as a tab for this page, and you can put bionic type connectors or ST connectors. 103, page 103. You can, okay, right here, second paragraph, the type of connector onto the quickly in the field. And I put quick mount connector as a tab in this page. All right, 106. First paragraph, from first word to connection. Second paragraph as well, from second to compression. And then you're going down to 4.10.1, fusion splicing. From fusion splicing to electrical arc. That's what that one. And then you can tap this page, fusion splicing. Moving along, page 115. Advantage of fiber and optical. Advantage of fiber and optic cabling. How you see structural cabling. You're gonna highlight structural cable onto bandwidth, and then you're gonna go and highlight signal loss all the way to a decibel per kilometer signal loss. You're gonna put advantage of fiber optics as a tab, and I'm gonna keep moving. And then you're gonna go page 133, and then you're gonna go to, excuse me guys, basic network models. Basic network models 6.3, and put a tab as a basic network models. And then let's go and here 6.8, start topology. Such network configurations are called hybrid networks. As you see here, such network configurations are called hybrid networks. Start topology. Start topology, highlight that, or hybrid network topology, tab that. Here, making the right connections. So you're gonna go 6.2, so aside from 6.12, sorry. So you're gonna go, I guess, to above summary. Just go above summary and 6.3, go above it, and then from the key to other software, highlight that and put, I tap this page Inter. Let me see. Wow, this is a interoperability. I don't know. Yeah, lands or van or ones or interoperability. Here we go. My English is not best. Digital subscribers line. Okay, in page 145, 7.1. We're in chapter 7. Highlight this complete book. This is complete book. Yes, you should. But now, you're gonna highlight the lines can be used currently for voice and data transfer and faxing. So they can use both. You know, the introduction of DSL. I think the main goal is that they can use voice and data. So highlight that. But a question will be structured like what they can use both, they cannot use both, they can use voice and data, they can use voice and internet, whatever. So get that, and yeah, put digital subscribers or DSL. So which stands for digital subscriber line, which is DSL. Okay, page 157. Planning the wiring installation. Planning the wiring installation. 8.1. All right, so I want you to highlight from planning all the way down to organizations. And then I want you to highlight the architect, the manager, the data communicator engineer, and the facilities engineering. Planning wiring system, TCM, tab for it. Okay. Okay, moving along here. So it's page 8.9, maximum power location and number of power outlets. Historically, users have been, I'm not going to read it. So the second paragraph, guys, second paragraph, all the way to the next page, 181, and then all the way here, and then 1, 2, 3. Okay. And then I put power crunch. I don't know why I put power crunch. This, yeah, but I put power crunch, I guess. You know, power crunch. Why would I put that? Oh, I think power strips. Oh yeah, boy, because power crunch is right here. And I was thinking about talking about crunch fitness. That's the gym that I go to. I say, well, where would I put that? All right, so going over here, 8.26, writing the request for bid proposal. First paragraph, you can put bid proposal. Hang tight, guys, hang tight. Central distribution points. Right here, the second paragraph, the most common onto by telephone companies. Highlight that. You can put a tab, central distribution point, this line, and then moving along here, we're going to page 204, and yeah, coaxial. You're gonna highlight coaxial until stretch it. And I tap this coaxial cable never be hung. Remember, I put whatever I can't remember. It's best, you know, because it becomes overwhelming. There's a lot of books and a lot of things. But yeah, and then I'm just giving you whatever I have. You don't have to go this deep, but if you want to go, if you ever bounce to this, I mean, you found this video, if you want to go deep all the way down to what I did, because I know it took me time. It took me, I think, 2 days to highlight and tap this book with the things that I have. And you're wondering, where did I get this from? Rocket Center. There's a link I have a link. If you go down, you're gonna see a couple of things. My Instagram is, everything is linked there. Rocket Center. That's what I get this from. And if you follow the things that I have published and the things that I've been doing, you will know that there's a test simulation that helped me pass the test, and it's right there. So you get the link. If you want to go forward, you know what to do. If you want to pass it and become the boss, you know what to do. I'm gonna tell you though. If not, just highlight everything I did, and go take the test. But without this simulation, without that exercise of those 50 questions, that is a test simulation that is gonna help you exercise your brain to remember where the question is, should I go and reach. That's the main goal. All right, going back. 210, page 210. Grounding cable systems. The most likely peak of electrical noise should be as follows: 1, 2, 3, and 4. Get it. Then, right here, primary protection. Simple as that, guys. You're gonna go to RMC, AC voltage, primary protected device, first paragraph and second paragraph right here. Just skip this little first one in. And remember, you can type this and tap it however you want it. I put 2 tabs in the book. I put grounding, the cable system, and then I put another one, LFD, EDI, EMI, RFI, acronyms. Sometimes some. Here we go. Yeah, acronym, because there's the page right next to it that has the acronyms and all that stuff. Yeah, right here. All the acronyms. Acronyms, guys. Those acronyms might come in the test. You know what I mean. You know what I'm saying. All right. So splice points. Very quickly. 224 splice points. 10.6. So from physical to losses, attenuation losses. Here we go. Tap that page. Make sure you tap it. Let me see. Moving along. Okay. Continuity test of a cable. Continuity test. From continuity is found. Then VOM, first lane. And then from 1 to 0 ohms. And I think the main thing is in here. Yeah, this continuity test is very important. All right, so yeah, follow the when VOM is used for continuity or short tests. A little below, when test leads are shorter on a continuity checker, the light will be illuminated. Highlight that, and let's go. Continuity text of cables. Tap that page, please. Don't give up. And yeah. All right, so we got here page 245, testing a coaxial cable. Here you go. The ground should be checked for the N to N for the continuity. A signal lead to ground test should be performed on every coaxial cable. Coaxial cable testing. Please highlight that. Let's go. You see a continuation of this highlight. On page 246. Let me make sure you highlight this whole paragraph. Okay, let's see. 11.9. As you see, the time domain reflectors with TDRs can be used to locate problems in any metallic 2-conductor cable, including the following. All of this, I don't know what I didn't highlight, but here. The TDR transmits signal down a wire at a certain speed. At the point of problem, some digital sign is reflected back to the unit. It's very important. And then back here in free air, the terminal travels approximately a speed of. Here you go again. Here you go, 186,000 miles. Why is that? Very important. That's a TRD formula. I don't think I never face problems like that. I think this is just explanation. And then here you see the ratio of the speed travels down the cables like vacuum, called velocity propagation, VOP. The light vacuum is 186,000 miles per second, or 200,000, or there you go. That's a little gem also, or 300,000 kilometers per second. That's something that's also tough too. Speed of light in a vacuum, you can tap that. Speed of light in a vacuum. And then we move into page 255. Here, second paragraph, cable loss return, auto signal return, and then the ratio, starting here, the ratio of a signal transmitted to return is called return loss, and a measured in decibel return loss, D. So they can ask you, what is it called when you lose the ratio or whatever, the return on decibel ratio, return loss. I think I did something with this in the book. That's why it might come and make you calculate the ratio, or here the table, blind spot distances. There's a table at the top. Let me see if you can see it. Yeah. Yeah, but definitely the ratio, and then here DBRL. So they ask you what type of ratio they use when you lost and measure decibel return. DRB DBRL. Tap that as well. You can highlight that. Going back over here, testing for fiber optic cable. 11.10 all the way to the bottom. The efficiency of fiber must be tested in an optimal domain reflectometer. Okay, very important. This testing fiber. And then you're moving along to page 259, and then you go the light of the signal, length of the cable, measuring. It takes a light travel into that. And then testing fiber cable. Optimal domain reflectometer meter. I put this on the tab. I don't know if you can put it. Moving along. Let me see. Almost done, guys. I know it's been a long video, but we're living in days now that people don't have attention span retention or something. But I know once you face this book, once you find this information, whoever finds it is gonna love it. It's gonna download it. It's gonna be so happy that someone took the time to do videos like this. Because this will help you tremendously. You just have to get it, and if you find it valuable, share it, subscribe to the channel, like it, help the algorithm pushes it more to people that need this information. And yeah, man, hope you know out of these things, those questions that might come in the test and help you pass. I'll be happy. Yeah, right, go. Okay, 11.13. Signal to noise ratio measurements. As you see, I highlight all of that stuff. And then moving along to page 263, I put like this is a little table right here on page 263. So make sure you put signal ratio, signal to noise ratio too. Remember that at the beginning, they make you calculate the ratio, guys. Remember that. Yeah. So this is examples, but I don't think they're gonna make you calculate none of these things. But I want you to read it and study trying to comprehend how they get to that result. Sometimes I can't remember right now, but yeah, this exercise is a very important signal to, let me see, right here, right at the top. um this this line, the second line, the third line, figure it out how they did it, go through the examples. um they will show you sometimes as a headache, but go through the examples, read it, trying to comprehend this. um as you're assisting again, you see that you read the sample, they make you add and subtract. So basically here, I think you just add the positive and subtract to the negative, and it gives you a result. Okay. Okay. Give me. I gotta. I call her back. Okay. I just want to finish this up. Sorry for the interruption, guys. But signal to noise ratio means. But I have it. My thing on silent. That's crazy. Phones nowadays, they want you to be on a phone because I have my things in silent. If I show you my things in silent and it still rings. I don't know why. Okay, almost done. Almost done. Okay. Page 264. Telephone communications companies to use 1 millimeter amp. That highlight that, and then as well, there's another table 11.11.5. Very important. Right here. The 1004 hertz reference level is called transmitted TLP, America, blah, blah, blah. Here, this paragraph from the 1004, highlight that, please. Highlight that. Make a tab for this table. Remember, make a tab for this table to learn and take a couple of minutes to understand why they, because any of these problems, it could be easier. It could be a math, or it could be just a subtraction. It's not hard. Just read it, trying to understand it, because you see here, moving along the other page 265, it will just give you numbers, and then if you see, it's just DMB less TLP, and that's it. It's not hard. DOB equals DOBN or TLP, and then 8 minus 12. That's it. So it's really simple things. You just gotta know what you're gonna do, because you don't know where they're gonna get you from. So 11.5, all of that stuff, calculate. There's another table here that I want you to highlight it and put the table information on it. And distribution in the last tab, it'll be 12.4, which be distribution lux. From the distribution lux and to the systems, all the way to the systems. Highlight that. Index, very important. Never miss your indexes. Index, highlight your index right here. It's there, but I want you to, when you need it, you need it. And then as well, glossary, which glossary means definitions. Like there's definitions, but this definition can help you to get used to it, walk through it a little bit. All of these definitions from A to C, it's like an index, and then there's a glossary, definitions of things. They might say ionized voltage, what it means. Ionized voltage is this. So get familiar with these terms in the book. Impedance, reductance, capacitance, reactance. All of those terms are here. Dielectric, noise, voice ratio, TMD, TRD, DLB. All of those things are here, and I hope you find this helpful. This is all the telecommunications and wiring, guys. I hope you find this helpful, and hey, you ever find this content, please share, like content, and leave a good positive comment so I can keep doing this type of content for people that are gonna need it, and they're gonna save time, and they're gonna be so happy there's someone helping out, and there's information, and there's not so much school selling you stupid things that might not help you. The only thing that helps me is Rocket Center, and there's another. So Rocket Center helped me with all of the books that we need to pass the EC in Florida. And for the NEC, Paul Abernathy and his academy, which are the two links that I have as an affiliate, those are the ones who help. me pass, because the NAC is something. Now the other two books, the other 14, 13 books, that's the other gem. So remember, Florida is the toughest. This is for tough people. Ain't for nobody. If I can help 100 people, that's fine. That's all I need. This is not for pussies or people that are gonna quit. You gotta keep doing. But the only thing that helped me, I didn't take Mile Bolt. I didn't take Mike Bolt or whatever. I don't know. Hey, kudos to him. That's fine. But I tell you what helped me was those two links that I have: the Academy for the NEC and this Rocket Center course. And if you like what I'm doing and you want to support a brother, here we go. Get and purchase the courses. All right. If anything, just keep studying, devise the book. And if you're good at reading, if you got good memory, hey, you're more than welcome to do it. I'm doing because I want to help, because I went through headaches and stuff like that, and I don't know where to study. And then probably also nobody tells you that yes, I took it 4 times. Ain't gonna nobody gonna tell you something. So here we go. This is it. It's not leave for more. Hey man, yeah, just subscribe, share, and download, man, and leave me a comment. Hit me up, contact me on social media, and say, hey, thank you for this. If not, just hate, dislike, and move along. I'm gonna let you guys go, and on to the next episode. Bye bye.